An arithmetic sequence is a sequence that increases or decreases by the same amount. So an arithmetic sequence looks something like 3, 2, 1. This is a very simple sequence. 0, -1. So in this sequence, the numbers are going down by 1. That's called the common difference. So we're going to let D be the common difference. In sequence notation, if you have a sub 1, so that's a subscript, it's a smaller number, that means the first term. So it would go a sub 1, a sub 2, a sub 3, a sub 4, ... a sub n. A sub n stands for the nth term. So in an arithmetic sequence, we have an explicit formula and we have a recursive formula. So an explicit formula looks like a sub n, so that's to find the nth term, equals the first term, which is a sub 1, plus the quantity n minus 1 times d. So n in this one stands for if there's 10 terms, if you're trying to find the 10th term, then n would be 10. If you're trying to find the 12th term, then n would be 12. So this is the first term and this is the common difference. So when you're writing the explicit formula, you always want to find the a1 and the d, and then everything else around here stays the same. A recursive formula for an arithmetic sequence would look like this. A sub 1 equals a sub 1. And then to get the nth term, you're going to take the previous term. So if you're trying to find the nth term, so if this would be like a sub 6, then a sub 6 minus 1 would be a sub 5. That stands for the previous term. So you're going to take the previous term and just add the common difference. So again, you would fill in this and this with a number. So I'm going to do a little bit of this recursive formula here. What is this recursion? What's the recursive formula mean? So if you had this recursive formula, a sub 1 equals 3, and a sub n equals a sub n minus 1 plus 2. What this means is you're going to take the first term is 3, and then you're going to take the previous term and add 2. So I'm going to take 3, which is the previous term. To get the next term, I'm going to add 2. So it's going to be 5. Then to get the third term, I'm going to take the previous term, which is 5, and add 2. Then to get the next term, I'm going to take the previous term and add 2. So that's kind of how recursion works. So looking at these examples, number 1, is a sequence arithmetic? If so, identify the common difference. So let's look to see if it's going up by the same number. It is. So yes, because if I subtract 10 minus 7, I get 3. If I subtract 13 minus 10, I get 3. If I subtract 16 minus 13, I get 3. So I'm going to put yes, D equals 3. So number 2, in order to figure out if this is arithmetic, I'm going to write down the sequence. So the first term is 7. To get the next term, to get the nth term, you take the previous term and then add 4. So it's going to be 11. So 11 plus 4 is 15. 15 plus 4 is 19. So yes, there's a common difference of 4. You can see it right here too. So yes, it's arithmetic. Okay, number 3, this set is called the triangle of numbers. So we're going to count the dots in each one. So this has 3 dots. 1, 2, 3, 4, 5, 6. This has 6 dots. This one has 10 dots. This one has 15 dots. So is 3, 6, 9, 15 arithmetic? The answer is no, because this difference is 3, this difference is 4, this difference is 5. So although there's a pattern to it, it's not arithmetic because it's not going up by the same amount each time. And then number 4, let's check to see if there's a common difference. So 39 minus 42 is -3. This is -3. This is -3. So yes, it's arithmetic, and the common difference is -3. And then this one is going up by 3, going up by 2, going up by 5. No, not even close. So if it's not arithmetic, you don't have to find the common difference. Next, we're going to find the missing term of the arithmetic sequence. So in order for this to be an arithmetic sequence, it has to go up by the same amount. So what we're going to do is find the arithmetic mean. So just like you found the arithmetic mean, or just like you'd find the mean of a data set, it's the same thing. The arithmetic mean is to add up, to find the mean. So to add up the two numbers and divide by 2. Because you're going to find the middle. You're finding the middle, the median between those two. So you do 50 plus 92 and then divide it by 2. And you get 71. So I would encourage you that if you're using a calculator, if you're having problems that you have to do the calculator for, make sure you're putting this quantity in parentheses. Because otherwise sometimes people do 50 plus 92 divided by 2 in their calculator. And this is just going to add 50 plus 92 divided by 2. So it's just going to add 50 plus 46. That's not going to be right. So an arithmetic mean always has to be between these two numbers. So you're going to add them up and divide by 2. So that now you can see that this difference is 11 and this difference is 11. Okay, number 7. Again, find the arithmetic mean. So what you're going to do is add up 24 plus 57 and then divide it by 2. So 24 plus 57 divided by 2 is 40.5. Okay, number 8, write an expression. So expression can have variables. It could have an operation that shows the arithmetic mean of A4 and A6. So the arithmetic mean of A4 and A6 is going to be A sub 5. So to find the A sub 5, you're going to do the arithmetic mean formula. You're going to add up A4 and A6 and divide it by 2. That will give you A sub 5. Okay, number 9. Use the explicit formula to find the 25th term in the sequence. So this is the first time that we're writing an explicit formula. So I'm going to write down what the explicit formula is from up top. So A sub n equals A sub 1 plus n minus 1 times d. And remember, we need to fill in the common difference and the first term into our formula. So if I'm trying to find the 25th term, I'm going to write it as A sub 25 equals, now I need to fill in the first term. So the first term is 5 plus n minus 1 times the common difference. So the common difference is I'm going up by 6. So this is the formula right here that I would use. So I'm going to plug in 25 for my formula. And actually you could write A sub n right here too, if that's the formula. But if I'm trying to find the 25th term, I'm going to plug in 25 in for n. So it's going to be 5 plus 25 minus 1 times 6. So that 6 is being multiplied. Now you can put the 6 in front or the 6 behind. It doesn't matter. So I do 5 plus parentheses 25 minus 1 times 6. And I get 149. So 149 is the 25th term. Okay, number 10. Find the third and 10th term of the sequence. So this is right now in a recursive form. So I'm going to generate the first 4 or 5 terms of this sequence, and then I'm going to write an explicit formula to practice and show you how to find the 10th term. So the first term is 5. And to get the next term, you're going to take the previous term and add 6. So it's going to be 11, then add 6, 17, then add 6, 23, etc. So the third term is 17. So to find the 10th term, I could just keep adding 6, but I'm just going to show you how to write an explicit formula right here. So it's going to be a sub n equals a sub 1, which is 5, plus n minus 1 times the difference, which is 6. So to find the 10th term, I'm going to do a sub 10 equals 5 plus 10 minus 1 times 6. So the 10th term is going to be 5 plus 10 minus 1 times 6. So it's going to be 59. So again, I could just use the recursive formula and kept going, but I wanted to practice that. Okay, number 11. Write the recursive formula for this. So to find the recursive formula, what I'm going to do is I'm going to write the first few terms of this sequence just so I could see what my a sub 1 is and what my d is. So if you plug in 1, it's going to be 3 plus 2 times 1, so it's going to be 5 is the first term. And then plug in 2, so it's going to be 3 plus 2 times 2, which is 7. Then plug in 3, it's going to be 9, etc. So now I can see that the first term is 5, and the difference is 2. So here's the formula for the recursive sequence. So recursive formula is a sub 1 equals a sub 1, and sometimes there's a bracket, and this is a sub n equals the previous term, which is n minus 1 plus d. So what we're going to do is we're going to fill in with numbers your a sub 1 and your d. So it's going to be a sub 1 equals 5, and then a sub n equals a sub n minus 1 plus 2. So I'm filling in the 5 and the 2. All right, number 12, suppose you have already saved $75 toward a purchase of a new iPad. You plan to save $15 a week from money you earn at a part-time job. In all, what is the minimum amount you will have saved after 26 weeks? So how much money have you saved after 26 weeks? So because we're adding 15 to each time, that's going to be an arithmetic sequence. So I have my a sub 1, and I have my common difference. So I'm going to use the formula a sub n equals a sub 1 plus n minus 1 times d. So the 26 weeks is going to be a sub 26 equals 75 plus 26 minus 1 times 15. So if I put that in my calculator and I do 75 plus 25 times 15, I get $450. So minimally, we should save $450.